Hello everyone. Okay, in this video I'm going to solve some example problems from type 1 improper integral. So here we have a type 1 improper integral. In the upper limit we have infinity. So this is a type 1 improper integral. So let's write it in the proper format. So let's replace infinity by t. Okay, a letter e to the x times e to the negative 5x, and let's take the limit when t goes to infinity. So I wrote the integral in proper format. Now to integrate x times e to the negative 5x, we need integration by parts. So we have to choose u and we have to choose dv. Now based on LIATE rule, we have an algebraic function here and an exponential function here. So the algebraic function comes top on the list, LIATE. So for u, algebraic function gets selected for u. So the choice for u is x, and dv is e to the negative 5x dx, the rest. Okay. All right. Now to use the formula, integration by parts formula, we have to find v. So dv is e to the negative 5x dx. So if you integrate the integral of e to the negative 5x, that's v, which is e to the negative 5x divided by negative 5, because we took the integral of e to the negative 5x. Now let's find du over dx. So derivative of x is 1, so du is dx. Okay, now we can use integration by parts to integrate, to evaluate this integral. So limit, don't drop that limit, keep on writing it. So if you use the integration by parts here, integration by parts formula, it's uv minus integral of v du. So u is x, v is e to the negative 5x over negative 5 minus v is e to the negative 5x over negative 5, du is dx. And you are integrating from 0 to t, don't forget. And you have to evaluate this part. Okay, you have to evaluate this part from 0 to t as well. Okay, right. So let's do this. So limit t goes to infinity. Okay, x times e to the negative 5x divided by negative 5. We have to evaluate it at t and 0. Okay, minus. Now let's first integrate this. If you integrate e to the negative 5x over negative 5, you get e to the negative 5x. You divide by another negative 5. That negative 5 and this negative 5 will give you positive 25. Okay, and this has to be evaluated at 0 and t as well. Okay, all right, so we are done with integration. Now we just need to evaluate these functions. So first evaluate this part at t. So if you evaluate, it's t times e to the negative 5t divided by negative 5, subtract. Now you evaluate at 0. So if you evaluate this function at 0, you're going to get 0, because x is 0. So 0 times e to the 0 is 1, so it's 0 anyway. Minus, now this part, so let's have a parenthesis so that we don't mess up with signs. So now let's plug t. So it's e to the negative 5t divided by 25 minus plug 0. So e to the 0 divided by 25, right? Okay, so let's simplify this. What do we get? Limit when t goes to infinity, okay, t e to the negative 5t over negative 5 minus e to the negative 5t over 25, okay, minus minus plus e to the 0 is 1, so 1 over 25. Okay, perfect. Now let's see what's the limit. Well, when t goes to infinity, this part will go to 0 because it's an exponential decay, right? Okay, and the limit of a constant is constant, so from there it's 1 over 25, so it's minus 0 plus 1 over 25 when we take the limit. How about the limit of this term when t goes to infinity? Well, this term goes to infinity, but e to the negative 5t when t goes to infinity, that goes to 0. But exponential function goes to 0 fast. So when you compare t and e to the negative 5t, e to the negative 5t goes to 0 faster than t goes to infinity. Okay, then t getting large. So it's basically a function that's getting large times a function that's really getting small, right? But the function that's getting really small goes to 0 really fast. So this whole term goes to 0, so that's 0. So the limit is actually 0 minus 0 is 0, 0 plus 1 over 25 is 1 over 25. So that's the limit. Oh, that's the answer for the integral 0 to infinity, if you integrate 0 x times e to the negative 5x from 0 to infinity, this is what we get. So the limit is finite, the area is finite, so this is a convergent, this integral is improper integral is convergent. Okay, all right, so let's move on to example 2. All right, so now let's solve this new improper integral. Now as you can see, it's an improper integral. We can see infinity in the limits. In fact, there are 2 infinities in the limits, right? So how do we handle this? I mean, there's a dilemma here. Who are we going to replace with a letter? Is it the top infinity limit or the negative infinity? Or who are we taking the limit with respect to? Do we let t goes to infinity or negative infinity? So there's a clear dilemma. So how do we handle this? Well, here's what we do. When we have infinity in both limits, what we do is we split the integral into 2 parts. Okay, so I'm going to write this integral as the first integral starting from negative infinity to 0. Now why 0? Well, it doesn't need to be 0. It can be any point as long as the function, as long as the function is continuous at that point, everything is good to go. So the function is continuous at x is equal to 0. So I can choose 0. You can choose 1, 5, doesn't matter. Okay. Now then the second integral, I'm going to write it from 0 to infinity. It's like I divided this infinitely long interval negative infinity to infinity into 2 parts. Okay, so I'm integrating over this big large interval, so I'm going to do it in 2 pieces. Okay, in two sections. First I'm going to integrate from negative infinity to 0, break there, and I'm going to integrate from 0 to infinity, and then I'm going to add both of the answers. That's what I did. Okay, all right, just a simple idea. Now that dilemma won't happen, because in the first integral we can replace negative infinity by t, and we can say, okay, limit when t goes to negative infinity. Okay, you are integrating from t to 0, so x e to the negative x square dx, plus now on the second integral we can replace infinity by a different letter b, and we can let the limit b goes to infinity x e to the negative x, integrate x times e to the negative x square. Okay, so simple fix. Right, now let's do the integration. Now if you want to integrate x times e to the negative x square, you have to use integration by substitution, because you can choose u to be negative x square. Okay, the gist here is derivative of u is actually negative 2x. So because of that, dx is going to be, if you divide by negative 2x, it's du over negative 2x. Okay, now we can do a simple substitution to both of these integrals. Okay, so let's see what do we get. Now in the first integral, it's x times e to the u, okay, dx is du over negative 2x. So see, x cancel out, and we just get to integrate e to the u over negative 2. So that's why we use integration by substitution, because it will give you a simple integral to solve at the end of the day. Now we can do the same in the second integral, okay, because it's the same criteria. So it's going to be x times e to the u, dx is du over negative 2x. So x cancel out, you are just integrating e to the u over negative 2 with respect to u. Now there's one more thing. Now the limits, they have to change. Okay, you have to write your limit in terms of u, okay, because these limits, they belongs to x. Now when x is equal to t, okay, so we have to change this limit. When x is equal to t, what's u? It's negative t square, right? So this is going to be negative t square. And when x is equal to 0, what's u? Well, 0 square is 0, so that's 0. When x is equal to 0, u is 0. When x is equal to b, what's u? It's negative b square. Okay, so then the limit when t goes to infinity, and limit when b goes to infinity. Okay, so don't forget to change the limits. Right, now let's evaluate these integrals. Limit when t goes to infinity, integral of e to the u over negative 2 is in fact e to the u over negative 2. Right, a simple integral. Now you want to evaluate them from 0 to negative t square. Here also same, limit b goes to infinity, just integral of e to the u over negative 2 is e to the u over negative 2. You want to evaluate them at negative b square and 0. Right. Okay, so now let's evaluate them. So limit when t goes to infinity. If you substitute 0 for u, it's e to the 0, which is 1. So it's negative half minus, now substitute negative t square. So it's e to the negative t square over negative 2. Okay, this negative here and this negative, let's make it positive. Right. Plus here limit when b goes to infinity. Now plug negative b square for u, so it's e to the negative b square over negative 2 minus, now substitute 0, so it's e to the 0 is 1 over negative half. Okay, negative, negative, positive. All right, so let's write this cleanly before we take the limit. So limit t goes to infinity, negative half plus e to the negative t square over 2, so that was already clean. Limit b goes to infinity, e to the negative b square over negative 2 plus half. Okay, I think I have made a mistake here, right? Yes, I have made a mistake because this t is going to negative infinity, right? So this t, rather than it's going to infinity, it's going to negative infinity. So my bad, it's a mistake from my part. So sorry about that. Okay, so t goes to negative infinity. Right, let's see what happens. So let's first find this limit. So when b goes to infinity, when b gets large, e to the negative b square, that gets very small, right? It goes to 0. So 0 plus limit of half is half. Plus when t goes to negative infinity, the limit of e to the negative t square, since t goes to negative infinity, this gets extremely large. It goes to infinity and this guy goes to negative half. So altogether the limit is infinity. Okay, so that means this integral is a divergent integral. Okay, all right, so those are 3 examples. Let's see another 3 examples in a different video. Thank you very much.